Hi, welcome back to Leetcode. So in this video, I'm going to discuss Leetcode problem 3761, minimum absolute distance between mirror pairs. Okay, so let's see the problem statement. You are given an integer array nums. Okay, a mirror pair is a pair of indices I and j such that 0 less than equal to I less than j less than nums length. That means I is less than j. So I will be present at the left side of the j. Reverse of nums I equals to nums of j, where reverse x denotes the integer formed by reversing the digits of x. Leading zeros are omitted after reversing. For example, if we reverse 120, it will be 21, not 0 to 1. Okay, so return the minimum absolute distance between the indices of any mirror pair. The absolute distance between the indices I and j is absolute difference between I comma I minus j. Okay, if no mirror pair exists, return -1. Okay, so that means we have to check that the minimum distance between two mirror pairs. So what is the condition for mirror pairs? Mirror pairs condition is that if you reverse the previous number or the left number, then it will be equal to the current number, right? So if it is equal, then actually we can say that this is actually mirror pair. So I have to find out the distance between these two elements. So I will know the index of left element is suppose I and the current element index is j. So our difference between will be I comma I minus j. Okay, so in this actually we have to count the maximum or minimum distance. Okay, because there can be many mirror pair actually possible, so I have to store only the minimum distance. Okay, if there is no mirror pair, then it will return the -1. Suppose let's take the example 1. 12 21 45 33 54. Okay, so this is our input array. So this is index 0 1 2 3 4. Okay, first of all, for this number 12, is there any in the left side, is there any number which is say reverse of that current or the previous number, it is equals to the 12? Because there is no element in the left side, so we are sure that there is no answer. So our answer will start with suppose int max positive infinity, because we have to count the store the minimum distance. So I'll instead do the positive infinity. Now go to the next number 21. Okay, 21. In the previous or in the left side, is there any number whose reverse will be the same equals to the current number 21? In the left side only we have only one element 12. So if I reverse this, that will be 21, right? Okay, this equals to 21. Okay, so this will be one mirror pair. So what is the distance between this? 1 minus 0, the distance is 1. So answer will be now 1. Got it? Next I'll go to the 45. Okay, 45. So ultimately we have to search about the 54. All right, in the left side, do you have any element 54? No. So this is not, there is no mirror pair with 45. Go to the next 33. So 33, reverse will be again 33. Is there any element in the left side of 33? No. So there is no mirror pair. So I go to the next number 54. 54, okay, its mirror will be ultimately 45. So I have to check that in the left side. In the left side means here in this range, any number present as 45, 12, 21, 40. Yes, there is 145. Yes, so that means 2 and 4, index 2 and 4 will create a one mirror pair. So the distance between this, it is 4 minus 2, it is 2. Clear? So, and previous distance we actually have 1. Is 2 is better than 1? No, because we want to show the minimum distance. So 1 is better. So we will not override this. Our answer will be still 1. Now we have reached the end of the input array. Our answer will be 1. Let's check. Is it our answer is 1 or not? Yes, our answer is 1. Clear? Now, what actually we can do? In the brute force approach, we can do is that 12, 21, 45, 33, 54. So for each number, I will iterate in the left side that is there a number of reverse of this current number 21. I will check that in the left side. Again, I will iterate from 0 to I minus 1. Okay, currently suppose I have an index I. This is index I. So I'll iterate from 0 to I minus 1. I'll check that is there a number which is equals to the current number 21. So if it is present, then actually we actually have some answer. Otherwise, if we reach the end of the index 0, that means there is no element as 21. Okay. Again, I'll go to the next index 21. So index is this index value is 21. This is now our I. So again, I'll iterate from 0 to I minus 1. That means this 0 to 12. Again, I'll iterate. I'll check that is there a number which is equal to 12. Okay. Yes, it is equal to 12. So I'll actually check the answer j minus I. Okay. Next, again for the 45, I'll again iterate the left side all the elements. So you can see that for each index I, I'll iterate the whole sub-array present in the at the index 0 to I minus 1. Correct? So for each I, I'll iterate the input array I. Right? For each ith element, ith index. So there will be n index, and for each index I will iterate the input array again from 0 to I minus 1. So it will take big of n. So actually you can see that our time slot will be big of n square. This is clear why the time slot will be n square. Because for each index I want to traverse the left side, means 0 to I minus 1, to check that is there a number which is equal to the reverse of this current number. If it is equal, then actually I will actually calculate the answer, or the distance, then actually I will check with the answer, this is actually better answer or not, better distance or not. Clear? So for each index I will iterate again the left side, so it will take n square, because there will be n number of index will be present, and for each index I will iterate the left side, so this will take n square. Clear? So this approach will not work. Now actually how we can solve this problem? So somehow if we do not want to we do not want to iterate, because anyway we have to iterate the input array, we cannot optimize that, because for each number we have to check that this is actually creating a pair or not, mirror pair or not. So we cannot optimize this I, but we have to check that do we really need to iterate the input array from 0 to I minus 1. If we somehow store in somewhere in the map the previous number we have seen in the left side, then it will be easy to check or easy to access. Suppose we actually have 12, 21, 45, 33, 54. So before starting with 12, our map will be empty. Correct? Because we have not seen any element in the left side. Okay, our map is empty. So I want to search that 21, because our reverse of 12 it is 21. So I want to search that is in the map, do we have seen any 21? No. So there is no mirror pair. And before going to the next number, I have to store 12 here. Okay, 12 here. In the map that index 12 actually I have seen in the index 0. Got it? Next, go to the next number 21. What is the mirror of this? 12. So I will check in the map, have I seen any 12 before in the left side? Because I am iterating from left to right. So yes, I have seen a 12 at the index 0. So I know the current index it is 1. So our distance will be 1 minus 0, distance it is 1. So our answer will be modified with 1. Clear? So before going to the next number, I will store 21 at the index 1. Okay. Now I will come to this this next number 45, index 2. So reverse of this will be 54. So I'll check in the map, have I seen 54? No. So there is no mirror pair. So before going to the next number, I'll store the 45 I have seen at the index 2. Okay. Next number is 33. Reverse number is again 33. Have I seen 33 in the map? No. So a map will say that this number I have not seen. So there is no mirror pair. So before going to the next number, I'll store that 33. It is present at the index 3. Got it? Now I'll go to the next number 54. The index it is 4. So what is the mirror of this or reverse of this? 45. So now I will check that have I seen 45? Yes, I have seen 45 at the index 2. So we can actually create a pair, mirror pair, right? This 45 and 54, correct? Because our search that reverse of this will be true, like equal. So if this current number is 54, the reverse of this will be 45. So 45 equals to this 45. Okay. So what is the distance for this? Index 4, current index is 4, and the 45 index is from the map. I can easily find out that what is the index for that. This is actually 2. So the distance it is 2, and I will check that this is actually minimum distance or not. If it is minimum, so I will modify the answer. But this is not a better answer, so I will not modify this our answer. Clear? So in the map actually we can easily store that, and we can easily find out that do we actually have any mirror pair or not, mirror number actually not, reverse number. So we don't need to check the whole left subarray again from 0 to I to check each every time that this reverse is present or not, this reverse is present or not, right? From the map we can easily find out that, correct? So in this actually we will take it will take big of n time velocity, because we are iterating each element only once, and to search in the map we know that this will take big of 1, right? To search that and to insert that, we're also at the end we're storing that also, right? This current number is present at the index 3, we're also storing that before going to the next number. So this will take big of 1 time velocity to we know that in the search operation, in the insert operation, in the average time velocity it will be big of 1. Okay, and for each time, for each element we are trying to check that is there any mirror pair or not, so it will take big of n ultimately. Great. If this approach is this algorithm is clear, now go to the code. So first of all we will take one map, we're storing the key will be string, because the you can also take the number also. Here actually I have string, because the reverse operation on string it will be easy. Otherwise if we have integer number, so we have to divide this, right? So if we convert this as a string, and you can easily actually by using the reverse function we can easily reverse that current string. What is the mirror of this current string, correct? So that's why I have actually used string. You can also use integer number also. You can also, by using, if you take the integer number, then you have to create another function to create the reverse number of the input number, okay, for integer number. Here actually I am string using string, and the integer indicates the what is the last index I have seen the current string, okay. And our answer will start with int max, means positive infinity. Now we start iterating from on the input array nums from left to right, I is equal to 0, I less than nums dot size, okay. So I'll get the current string or the current number, I'll convert this current number to the string, okay. That means 12 is our current string, okay. Now what will your target? Target is to get the 21. In the left side, have we seen any 21 or not? So that's why in the map I'll check that have I seen the current string 12. Why am I searching 12? Because when actually going to the store, before the next number, I'll store the reverse number. I'll store that. That's why I'm searching the current number explicitly 12. Okay. So I'll search this, have I seen in the map, have I seen 12? If it is present, so I'll store the distance. So current index is I, and the last index it is actually map of current index, current string. Okay, so it's actually written the last index. Actually I have seen the current string. Okay, next if actually found this is our answer. Okay, and reverse this current string before going to the next number 21. I have to store this as a 21 because I am searching as a 21, right? You can see that whatever the current number, I am searching this in the map. Okay, not reversing this. So first of all, reverse the current string 12. So now actually it will have actually 21. Okay, so but they mentioned that after reversing, if we have leading zeros, that should be omitted, right? So that's why after reversing, now actually I have 21. So I'll iterate from left to right. Suppose we actually have input string as 120. So after reversing, our string will look like 0 to 1. So that's why I have to omit these two. So that's mean I have to store ultimately 21. So that's why I will iterate from left to right. That is it 0. So that's why I'll start from j is equal to 0. So I'll check that if it is j is less than the current string size, and if the current index, because I'm starting from left to right, if it is 0, that means I have to subtract, or we have to discard this from the input string. So that's why I'll increase the j plus plus. So j indicates the first index, where actually we have a non-zero character. Clear? So I know the starting index, where actually we have the first non-zero character. So first of all, then we have to store that. So that's why I'll create a new substring start with the index j. So that means j will indicate, j value will be, j value for this situation, j value will be 1. So I'll create a new substring of index 1. So that means it will return 21. So our string reverse, it will actually return 21. Clear? And I'll store that 21 at the index 0. In the map, you can see that I'll store the key will be the 21, and the index, it will be actually index 0. Got it? So you got the logic. Why actually I'm directly searching the current string. because I have already reversed the previous string. Because when I am storing in the map, I will first reverse this string and then store it into the map. So that's why I will directly search the nums of j, is it present in the map or not. If it is present, I will calculate the distance and I will actually compare with the answer. Else I have to go to the next number. So before going to the next number, I have to store the reverse of this current number. So that's why first of all reverse this, and we have to handle this situation also where reverse of 20, it will 120, it will be 21. So that's why I first reverse that, and I will check the first index of non-zero character, first index. So this file will actually handle that, and then actually create a new substring starting with that character and store this into the map. Now go to the next, again the next number. So next number it will go to 21. So 12 it will actually store in the map, 12, 21 it will store at the index 0. Next I will go to the next number 21. Okay, 21 it is present in the string map, yes, and the index it will actually 0. Got it. Next number again I go to the next number, it will be actually 12. Got it. Reverse of this, it will be 12. So I'll store this into the map. Got it. Again next again I'll go to the 45. I'll check in the 45 is it present in the map or not. Not present, so I'll store in the map as a 54 and the index it will be 2. Again I'll go to the next number 33. Got it. This for loop will go to the next number. Again I'll check that is it in the map, have we seen 33. If it is not present, I'll go to the continue to the line number 11 and I'll reverse that first string, and then it will store handle the if there is any leading 0, and then it will store it into the map. Clear. And they mention that if there is no mirror pair exists, return -1. So how can actually check that our answer is our answer should be -1? If our answer is still int max, that means we have not found this if is never true, right? This if never true, so our answer will not modified, so our answer will be still int max, so I'll return -1 that time. Clear. And else whatever actual answer I have, return that. Clear. I hope this is clear. I actually explained this in simple way and also explained the first brute force approach, right? Then this optimal approach by using the map. So I have shared this code in the description, you can check that, and if you like the explanation, please like the video, and if you are not yet subscribed, please subscribe channel. Thank you. Bye.